When wiring a 230 volts, 77 amps welder operating at a 60% duty cycle, several factors must be considered to ensure safe and code-compliant installation. These include conductor sizing, overcurrent protection, which is also called OCP, and the type of disconnect required. Firstly, let's talk about conductor size calculation. According to section 630.11 of the National Electrical Code, also known as NEC, the conductor size must be calculated based on the welder's primary current and a multiplication factor. In this case, the conductor rating is determined by multiplying the welder's primary current of 77 amps by a factor of 0.78. This calculation yields a conductor rating of 60.36 amps. Since conductors are not typically manufactured to exactly match calculated ampacities, you must select the nearest standard conductor size that meets or exceeds this rating. In this scenario, number 10 American wire gauge, which is also known as AWG copper conductors, are sufficient, as they are rated to carry at least 60.36 amps, complying with NEC Table 310.16. Secondly, let's discuss overcurrent protection, which is also called OCP. Overcurrent protection is essential to protect the welding circuit from overloads and short circuits. The National Electrical Code specifies that the overcurrent protection device should not exceed 200% of the welder's primary current. For a 77 amps welder, the maximum overcurrent protection is calculated by multiplying 77 amps by 2.0, resulting in 154 amps. Therefore, a 150 amps overcurrent protection device, such as the circuit breaker, would be suitable for this installation, as it falls within the allowable limit. The circuit breaker serves as the overcurrent protection device and is designed to trip and interrupt the circuit in the event of an overcurrent condition. This helps prevent damage to the welding equipment and the electrical system. Now let's talk about disconnect requirements. A disconnect is required to provide a means of safely disconnecting power to the welder for maintenance or in case of an emergency. The type of disconnect, whether fused or non-fused, depends on specific installation requirements and local codes. Firstly, let's consider fused disconnects. If a fused disconnect is used, it must be fitted with fuses rated at 150 amps or less, matching the overcurrent protection device. The fuses provide an additional layer of protection, ensuring that the circuit is interrupted if the current exceeds the fuse rating. This is particularly important in industrial settings where welders may be subjected to frequent use and potential overloads. Secondly, let's consider non-fused disconnects. If a non-fused disconnect is selected, it must be rated for the maximum fault current at the point of installation. Fault current is the amount of current that would flow in the event of a short circuit, and it can be significantly higher than the normal operating current. Determining the maximum fault current requires an electrical calculation which takes into account the available fault current from the utility company, the impedance of the electrical system, and the distance from the power source to the disconnect. This calculation is essential to ensure that the non-fused disconnect can safely interrupt the fault current without failing or causing damage to the equipment. As a recommendation for a 230 volts, 77 amps welder, it is generally recommended to use the following wiring configuration. Use number 10 American wire gauge copper conductors, as they are adequately rated for the calculated current. Install a 150 amp circuit breaker as the overcurrent protection device to protect the circuit from overloads and short circuits. Use a non-fused disconnect rated for the maximum fault current at the point of installation. This configuration provides a balance of safety, reliability, and cost-effectiveness. By following these guidelines, you can ensure a safe and code-compliant installation for your 230 volts, 77 amps welder, protecting both the equipment and the electrical system from potential damage.